In this video, we'll introduce AssistMimic, a framework for physics-grounded human-human assistance. Our goal is to train humanoid controllers that can physically support mobility-limited partners, such as helping someone stand up from the floor. AssistMimic formulates this as multi-agent reinforcement learning, jointly training a supporter and a physically constrained partner in a physics simulator. By leveraging motion priors, a single policy can reproduce a wide variety of assistive motions across different scenarios and body configurations, moving toward general controllers for physical assistance.
Next, let me highlight why this problem is so challenging. On the left, the top row shows a low-contact high five, while the bottom row shows a contact-rich help-up motion, and we compare the learning curves for these two settings. With the vanilla policy that only takes each agent's own state and the partner state as input, we can see from the two graphs that learning becomes dramatically harder once the motion depends on sustained contact and supportive forces to the partner. In such close contact assistive scenarios, even small errors in contact location or force magnitude can easily destabilize the recipient, making multi-agent reinforcement learning extremely hard to train stably. On the right, we show another difficulty. In real motion capture of close interactions, the bodies often occlude each other, especially around the hands and arms. This produces noisy and inaccurate demonstrations, so the controller has to learn meaningful support behaviors from imperfect reference trajectories rather than clean ground truth data.
Next, let me walk through the AssistMimic pipeline. Our framework has three key components. First, we use weight initialization from a single-person tracking controller. Both the supporter and the recipient start from the same PHC-style prior policy, which is already good at standing, walking, and tracking single human motions. In our network, the proprioceptive part of the input reuses these pre-trained weights, while the new assistive features are zero-initialized, as shown on the left. This lets the policy begin with reasonable motions and then gradually adapt to interaction using the additional inputs, which greatly improves exploration in the large joint action space of two coupled humanoids. Without such motion priors, naive exploration tends to fall into unstable poses or reward hacking behaviors instead of discovering meaningful assistive strategies. Second, we introduce a contact promoting reward. When the supporter's hands are far from the recipient, we use standard tracking rewards. But once the hands are close to the recipient's upper body, we switch to a reward that encourages stable contact and appropriate supporting forces, rather than strict adherence to the noisy mocap hand trajectory. This helps the policy learn physically meaningful support even when the demonstrations are corrupted by occlusions. Third, we use dynamic reference retargeting. Instead of following a fixed hand trajectory in world coordinates, we continuously retarget the supporter's hand reference relative to the recipient's current pose. This keeps the intended contact point on the body even if the simulated recipient drifts away from the original motion, and is crucial for maintaining valid close contact assistance. Together, these three components make multi-agent RL on contact-rich assistive motions trainable and lead to stable, physically consistent support behaviors.
We evaluate AssistMimic on two datasets. InterX provides diverse help-up motions from the floor, while HHI Assist contains caregiving motions on a bed or chair. For these datasets, we also test our tracking controller under unseen recipient dynamics, such as further reduced KP-KD gains and lower maximum joint torques. Across both datasets, our modules achieve high success rates. Weight initialization from a single motion prior enables us to realize these complex assistive motions for the first time, and contact-promoting rewards, together with hand retargeting, significantly improve robustness to unseen recipient dynamics, especially on HHI Assist.
To summarize, we introduced AssistMimic, a multi-agent reinforcement learning framework for contact-rich human-human support motions. By leveraging a single-person motion prior for weight initialization, together with dynamic reference retargeting and assistive contact-promoting rewards, our controller generates stable and realistic cooperative behaviors. This allows us to effectively assist recipients with various physical limitations through a wide range of support motions, paving the way for more general, physically grounded assistive controllers in the future. Thank you for watching.